Good day. I am Polaira Marmalabag, and my report is about Cloverleaf Interchange. What is Cloverleaf Interchange? A Cloverleaf Interchange is a type of road junction that allows for the efficient and safe movement of traffic between two intersecting highways or major roads. It is designed to minimize conflicts and provide seamless transitions between different directions of travel. The interchange gets its name from its resemblance to a four-leaf clover when viewed from above. It consists of a series of ramps and loops that allow vehicles to enter or exit the highways in a flowing manner, eliminating the need for traffic signals or stop signs within the interchange itself. Example of Cloverleaf Interchange in the Philippines is the Balintawak Interchange. It also known as the Balintawak Cloverleaf. It is a two-level Cloverleaf Interchange in Quezon City, Metro Manila, Philippines, which serves as the junction between Epifanio de los Santos Avenue and the North to South Expressway. Now, let's watch a video about Cloverleaf Interchange.
This is a Cloverleaf Interchange. They were built to allow two highways to cross without the need for traffic lights, or even harsh left or right turns. The advantage of the design was that drivers could turn from one road to another without stopping and without having to make a left turn across the path of oncoming traffic. With a Cloverleaf, drivers transition left by swinging right on the circular loop under an overpass. There are some definite benefits to the Cloverleaf. It has a relatively low construction cost because only one bridge needs to be built. Other interchanges, like the directional interchange, require many more bridges, ramping up the cost significantly. Cloverleafs can be easily upgraded by realigning slip roads, which are those roads you speed up on to get on the highway. And if you make a wrong turn, it's easy to correct by just going around the circles. Cloverleaf interchanges were built for a world where land is cheap and bridges are expensive.
Let's proceed to the project scheduling of Cloverleaf Interchange. Phase 1. Preparatory work. Task: obtain necessary permits and approvals. Duration: 1 month. Conduct site surveys and environmental assessment. 2 weeks. Clear the construction area and relocate utilities. 2 months. Set up construction site facilities. 2 weeks. Phase 2. Earthwork and grading. Task: excavate and grade the site. 3 months. Construct retaining walls if required. 1 month. Prepare, subgrade, and compact the soil. 2 weeks. Phase 3. Bridge construction. Task: construct bridge foundations. Duration: 2 months. Erect bridge piers and abutments. 1 month. Install bridge girders or beams. 2 months. Construct bridge decks and approach slabs. 2 months. Phase 4. Roadway construction. Task: build the main line and ramps. Duration: 3 months. Install drainage systems and culverts. 1 month. Pave the roadways and apply road markings. 2 months. Install traffic signals and signage. 2 weeks. Phase 5. Landscaping and finishing. Task: landscape the interchange area. Duration: 1 month. Install lighting and complete electrical work. 2 weeks. Conduct final inspections and address any deficiencies. 1 month.
Phase 1. Preparatory work. Obtain necessary permits and approvals. This activity involves obtaining the required legal permits and approvals from relevant authorities before commencing construction. It includes submitting applications, meeting regulatory requirements, and securing permissions for the project. Conduct site surveys and environmental assessments. During this phase, surveys are conducted to gather detailed information about the site, including topography, soil conditions, and any potential environmental impacts. Environmental assessments evaluate the project's impact on the surrounding ecosystem and help plan mitigation measures. Clear the construction area and relocate utilities. This activity involves clearing the construction area by removing existing structures, vegetation, and obstructions. Additionally, utilities such as water pipelines, power lines, or telecommunications cables may need to be relocated to make way for the interchange. Set up construction site facilities and temporary access roads. In this activity, temporary facilities such as offices, storage areas, and worker facilities are set up on site. Temporary access roads may also be constructed to facilitate movement of construction equipment and materials. Phase 2, Earthwork and Grading. Excavate and grade the site for the interchange. This activity involves excavating the site to the required depth and shaping the terrain according to the interchange design. It includes earth-moving operations, such as digging, filling, and compacting the soil. Construct retaining walls. If required, retaining walls may be necessary to provide support and stability to the interchange structure, especially in areas with significant grade changes. This activity involves building walls using various materials, such as concrete or steel, to retain the soil and prevent erosion. Prepare subgrade and compact the soil. The subgrade refers to the prepared surface on which the interchange will be constructed. This activity includes compacting the soil to ensure a stable foundation and adequate load-bearing capacity for the subsequent construction phases. Phase 3, Bridge Construction. Construct bridge foundations. This activity involves building the foundations that support the bridge structures. It may include activities such as drilling deep piles or constructing spread footings to provide a stable base for the bridge piers. Erect bridge piers and abutments. Bridge piers and abutments are erected to support the bridge superstructure. Piers are vertical structures built in the water or on land, while abutments are horizontal support structures at the ends of the bridge. This activity involves constructing these elements to the required specifications. Install bridge girders or beams. Bridge girders or beams are installed to create the framework for the bridge deck. This activity includes lifting and placing these structural elements into position, often using cranes or specialized equipment. Construct bridge decks and approach slabs. Bridge decks are built on top of the bridge girders, forming the driving surface. Approach slabs are constructed to smoothly transition between the bridge and the adjoining roadway. These activities involve concrete or asphalt paving, reinforcement placement, and finishing work. Phase 4, Roadway Construction. Build the mainline and ramps. Mainline highways and ramps are constructed to connect the interchange with the existing road network. This activity involves grading, compacting, and paving the road surfaces, as well as constructing appropriate drainage systems. Install drainage systems and culverts. Drainage systems, including stormwater drains, culverts, and ditches, are installed to manage water runoff from the interchange and prevent flooding. This activity includes excavation, pipe installation, and backfilling. Pave the roadways and apply road markings. Roadway surfaces are paved using asphalt or concrete, providing a smooth driving surface. Road markings, such as lane lines, arrows, and symbols, are applied to guide traffic safely through the interchange. Install traffic signals and signage. Traffic signals and signage are installed at appropriate locations within the interchange to provide guidance and control traffic flow. This activity includes setting up signal poles, wiring, and installing signage according to traffic regulations. Phase 5, Landscaping and Finishing. Landscape the interchange area. This activity involves planting trees, shrubs, and other greenery within the interchange area to enhance aesthetics and provide environmental benefits. It may also include installing irrigation systems and implementing erosion control measures. Install lighting and complete electrical work. Lighting systems, including streetlights and signage illumination, are installed to ensure visibility and safety during nighttime. Electrical work involves connecting the lighting systems, as well as any other electrical components required within the interchange. Conduct final inspections and address any deficiencies. In this phase, thorough inspections are conducted to ensure that the construction meets the required standards and specifications. Any deficiencies or issues identified during inspections are addressed and rectified before the interchange is open to traffic.